So welcome back. In the previous session, we defined what a vector is and gave a few definitions relating to vectors. And we also gave the different notations of vectors. So we'll continue giving further definitions relating to vectors and then state the vector algebra laws. So let's define what we call null and proper vectors. Null vector. So a vector whose magnitude is 0 magnitude is 0 and no specified direction is called no specific. Actually, specific or specified, the same thing. With no specific direction is called a null vector. And is usually denoted by or we can write 0 and then you put tilde below it. So that's what we call a null vector. So we can, in the plane, we can write null vector as 0i plus 0j. So all the components are have the value 0, or in the case of 3, this space we have 0i, 0j plus 0k. So that's a null vector. Now there's also what we call a proper vector. So a vector that is not null is called proper. So that's to simply mean a vector whose magnitude is not 0 and has a specific direction specified called proper vector. And then next, let's now see how we represent vectors. In the plane. So represent, so in form of a question, represent the following vectors as directed line segments, line segment in the plane. So first one, we have the vector u given by 2, 3, and 2. We have the vector v given by -1, 3. So to do this, I just draw the xy plane and then identify the coordinates. And then we'll read the values from those coordinates. So solution. So here Roman 1, then Roman 2. So this my y-axis. This my x-axis. And then in this other one, this is the x-axis. This is the y-axis. So 1, 2, 3, 4. 1, 2, 3, 4. So 0, 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3. So 1, 2, 3, and 2, 3. So 0, -1, -2, -3, -4, -1, -2, -3. 1, 2, 3. 1, 2, 3. So for this one, just I plot the point 2, 3. So that means 2 units along the x and 3 units along the y. So we'll have 2 units along the x. So we have this. And then 3 units along the y. So this is so that will be this point here. So this is 2, 3. And this being our origin. So then we draw a directed line segment from the origin to that plotted point. So we have so that's the point. So therefore, this is a vector u. So this is a vector u 2, 3. So that's what we have. And then for this other one, so -1 on the x and then 3y. So this is what we'll have. And then this 3. So this is a point. And then this being our origin. So you draw a directed line from the origin to that point. So that this is v of coordinates minus v vector -1, 3. So this is a point where we have -1, 3. So that is how we plot or represent the vectors in the plane. So the thing is just identify the coordinates and then draw directed line segment from the origin to that specific point in the plane. So let's now give the laws of vector algebra for vectors. So laws of vector algebra. So let A, B, and C be vectors. So let A, B, and C be vectors. And C, M and N be any real numbers. So real numbers of just scalars. Then the first one, A plus B is the same as B plus A. So vector A, so we are assuming that vector A, B, and C are conformable for addition. So therefore, when you say A plus B is the same as B plus A. So this is called commutative law for addition. To commute simply means to change the order. So changing the order, get the same result. So commutative law for addition. Then 2, if I have A plus B plus C, the same as A plus B plus C. So this is what we call associative property or associative law for addition. Associative law for addition. And then number 3, if I pick a scalar M, I multiply by A, is the same thing as saying A times M. That's called commutative law for multiplication. And then number 4, if I have M plus N, these are the scalars, I multiply by vector A, I'll get MA plus NA. This is called associative property for for a distributive property for A distributing on these colors A and M, M and N. So this is distributive property of distributive law. So property or law, same thing. And then number 5, if I have M into A plus B, I have M A plus M B. This is still distributive law. And number 6, if I have M times N times A, it's the same thing as saying Mn and then times A. That's associative property for multiplication. So that's associative property for multiplication. Associative property for multiplication. Or law for multiplication. This is simply scalar multiplication. So that's what we have. So let's do some examples. Application of these laws. So examples. Evaluate the following. Given that, so I have U vector is given by 3, 4, and so U, V, and W. V vector is -2, 5, and W is given by 2, or say 3, -4. Say -3, -4. So 1 is 2U plus V minus W. And then 2, I have U plus I have W. So solution for this will have 2 and then U is 3, 4, plus V is minus 2, 5, and then minus W is minus 3, minus 4. So let's start by solving this one first. So scalar multiplication. So these two multiplies every number in this vector. We'll have 2 by 3 is 6, 2 by 4 is 8, and then plus minus 2, 5, minus 3, then minus 4. So this is, we add corresponding elements. So this is the same as 6, and then plus minus 2, minus 3, and then 8 plus 5, minus 4. So that will give us so 6 minus 2 plus 3, 8 plus 5 plus 4. And this will give us, so 6 plus 3 is 9 minus 2, 7. And then 8 plus 5, 13, 13 plus 4, 17. So therefore the vector will be 7, 17. And for this other one, it will be a half. U is 3, 4, plus a half. W is minus 3, minus 4. So a half multiplies every element in this vector. So I'll have 3 over 2, half of 4 is 2, plus a half of this minus 3 over 2, a half of this is minus 2. And then you add corresponding elements. So I'll have 3 over 2 plus minus 3 over 2, and then 2 plus minus 2. So this will be 3 over 2 minus 3 over 2, this is 0, and then this also 0. So I have U plus I have W results into a 0 or a null vector. And then example 2. Example 2. If given A is 3i plus 4j plus 5k, and B is a vector 6i minus j plus 8k, find 2a plus 3b in the form ai plus bj plus ck, and then find the magnitude of 2a plus 3b. So this is the problem. So to solve this solution, the first, let's get 2a and 3b. So we'll have 2a will be 2 into 3i plus 4j plus 5k plus 3b. So 3b will be 3 into 6i minus 3j plus 8k. So these two multiplies every component of I, j, and k. So we'll have 6i plus 8j plus 10k plus 18i minus 9j plus 24k. So you add corresponding vectors. So i's together, j's together, and k's together. So we have 6i plus 18i plus 8j minus 9j plus 10k plus 24k. So this will give us 24i minus j plus 34k. So that's the first part. And the second part, magnitude of 2a plus 3b will be the square root of 24 squared plus minus 1 squared plus 34 squared, which will be now 24 squared plus minus 1 squared plus 34 squared. That is square root of 1733, which will be 41, 41.62931.659 units. So that's what you get as the solution to that given problem. And then C, given A is 2i plus 3j plus 6k, and B is given by ai plus alpha j plus beta k, find A, alpha, and beta if 2a plus b is a null vector. So this question is just testing on whether you know how to define the term null vector. So null vector is a vector whose magnitude is 0 and also every component is 0. So therefore, let's to find the solution, get a sum first. So 2a plus b will be twice 2i plus 3j plus 6k plus b is ai plus alpha j plus beta k. So we'll have 4i plus 6j plus 12k plus ai plus alpha j plus beta k. Then we have 4i plus ai plus 6j plus alpha j plus 12k plus beta k. So this would be 4 plus ai, 6 plus alpha j, 12 plus beta, k. So this is what gives us 2a plus b. And then given 2a plus b is a null vector, then this implies that 2a plus b must be equals to 0i plus 0j plus 0k. So i.e. that 0i plus 0j plus 0k equals to 4 plus a I plus 6 plus alpha j plus 12 plus beta k. So remember, just note two vectors, a given by a 1i plus a2j plus a3k, and b given by b1i plus b2j plus b3k are equal if and only if all the corresponding components are equal. Are equal if and only if and only if a1 equals to a2 equals to b1, a2 equals to b2, and a3 equals to b3. So this is a condition that you're going to use to solve for a, alpha, and beta. So this means that 0 should be equals to 4 plus a, which means that a equals to minus 4. And then 0 should be equals to 6 plus alpha, which means alpha must be minus 6. And 0 should be equals to 12 plus beta, which implies that beta must be minus 12. So that's how we solve that problem. So thank you.